Hey everybody, it's Mark again, and we are working on the 100-day anniversary clock made by Nisshindo Clock Company, Tokyo, Japan. I got the movement back together. First of all, before anybody says anything, I should be wearing gloves. The oil in your hands will discolor the movement. I don't have any gloves. I'm going to have to buy some. Plus, the gloves. Long story short, they irritate my hands, but I need to buy some gloves, disposable gloves. That way I don't get the oil from my hands on the clock. So, but anyway, I got the movement back together, and as you can see, when I rotate this wheel, it is rotating easily. When I rotate these wheels, they're rotating easily. So if I was to put some power on it, it would move properly. All right. Next up, I did find it in the 400-day clock repair guide. Here it is. Nisshindo movement says it was made in 1957, and I believe this one's got a different date on it. Let me look again. 1961 is when it was presented to the company, so maybe it was made in 57 and it hung out for a couple years, or maybe it was initially made in 1957 and this particular clock was made in 1961. I don't know. It says it uses 0.0028 inch or 71 millimeter spring, 3 or 4 ball pendulum 100-day clock, units 46 and 46A, see Appendix 121. Let's go to 46 and 46A. These are the units right here, 46 and 46A, and the information on them is on this page, and they both say 12 beats per minute. They both say the kind of spring it uses, but for 46A it says parts for this unit are more available than they are for the unit 46. Units 46 and 46A are interchangeable. Unit 46A is recommended. And then it said to see, forget. I had my, it says see Appendix 121. Appendix 121. This is an inexpensively made 100-day movement by Nisshindo, Japan. Has pen pallet escapement, mainspring housing riveted to the back plate, and a self-contained alarm clock type winding key. The pendulum is shown in section 13, pendulum 79. We'll go ahead and show you that real fast. Here's pendulum 79, which mine is a 4-ball, where this one's a 3-ball. But if you look at that versus mine, they're basically the same thing. So now let's discuss the most difficult part of working on one of these clocks. And that is to change out the spring. Now, before I go into that, I want to say I was on Time Savers a while back, and I bought these different suspension spring units. But the problem is they don't give you the size, So I went to Time Savers before starting this video, and I started searching these part numbers, and 90%, there's only like 2 part numbers that was in there. And so I don't want to work on my most expensive torsion clock prior to gaining experience. So I'm starting off with this cheaper torsion clock to gain experience, and I don't really care what size the spring is. I know what size it's supposed to be, so please don't complain that I'm using the wrong suspension spring. The purpose of this video is to help me gain experience on repairing these clocks. Like I said, I used to repair these clocks. It's been over 15 years since I repaired one of these clocks. Okay, most difficult is creating this suspension spring. Back to the book. I want to have that open. Here it is. Thanks to my group expert, Torsion Derek is his name, but is a YouTube video, and again, I will have his YouTube video link in the bottom of the description on these videos. I will put a link toward his YouTube channel at the end screen of these videos. But there's actually a guide that you could purchase, and the guide is fairly expensive. Last time I checked, it was like $80, $85, maybe more. And the guide basically helps you build this suspension spring in it. But what Derek does, he takes a board that has a slot in it, and he puts that spring in the slot, and then he lines up the bottom block, the fork, and the top block while that spring is in the slot. Thanks, Derek, for your ideal. I took your ideal and I went one step further. This is a piece of paneling, floor paneling. I put a slot in it, and then I put a piece of tape, and using my fingers, put that piece of tape in that slot. And the purpose behind that, I took my calipers and I measured the outside diameter of this spring. Outside to the top of the top block, to the bottom of the bottom block, and that's what these marks right here is. This is the bottom of the bottom block, this is the top of the top block. And then I took my caliper and I measured from the top of the bottom block, and I made a mark right here. And then I took my caliper to the bottom of the pallet fork, and I made a mark here. And then I put a piece of tape here, meaning the pallet fork goes to the right as I'm looking at this piece of board right here. So I could close the book because I don't need it, because I've got my template right here. Some people will use the book alone, and they will put the spring together by using the book alone. I don't want to damage my book, and that's why I don't use the book alone. And that's why I like Derek's ideal, but I modified his ideal and came up with this ideal. I already got the bottom block on, so I can stick it right here in this diagram I got, and as you can see, it lines up with my marks. So now I have to take the pallet fork off and put it on the spring, and that pallet fork is going to go right there because my piece of tape is to the right, and that's the way the fork is going. So let me go ahead and do that. Again, this is the most difficult part of working on these clocks, is creating this suspension unit. You could purchase some through, again, I know I'm butchering these people's name. I'm extremely sorry, but you could purchase some through Oliver. And I put their webpage in the last video I made on the suspension, on these torsion clocks. I might do that on this clock also. So now I'm going to carefully put this fork on the spring, hopefully. I got the screws loose. I had them on the spring. I'm lining everything back up. I'm bringing the fork down to my marks. And then I'm going to see if I can tighten this screws up without anything moving. Maybe I get a pair of tweezers, it might help me. Again, I am no expert on these things. My expert is Derek. So if you have questions that I can't answer, ask Derek. Verifying everything, it still looks good to me. Now it's time to put the top block on. But in order to put the top block on, I have to take this old wire out. Which, it came out. But I need to loosen these screws so I can tighten these screws. making sure there's no spring in it. I got the top block ready to go in the spring. And it's on the spring, and now I have to line everything back up and push this top block down to where it needs to be. And then tighten up the screws. And now I have to do is cut the excess off. Okay, next step I want to talk about is something I mentioned in the other video. And stand by, let me show you something. I showed you this diagram in the other video, and I say that if you were to copy this and cut this out, you put that onto this plate. That diagram is supposed to help you in setting the beat on the clock. I have done that in the past, and this is the issue that I have with what I just told you. You have to make sure that diagram is flat onto this base, so therefore you have to tape it down. And then you get it all in beat, you have to take your tape off and the diagram off, and then you figure out that maybe it wasn't quite in beat like you thought it was, so you tape it back down. It's a pain in the butt. If the paper curls up, remember in the other video I told you, friction will stop your clock. So I don't use that diagram anymore. And what I can suggest is, let me set my camera back up on this tripod. Stand by.